Welcome to School of Advanced Chemistry. I'm Khizar Chukhtai and you're watching my YouTube channel. Today I'm going to explain tips and tricks to write an ionic equation for the given balanced equation. Let's get started. What is an ionic equation? Basically, ionic equation is an equation that is exhibiting ions and compounds. Ions, those are making from a compound, and they are responsible for the net chemical change of the reaction. So ions and compounds, those are cause of that reaction. They are the cause for the net change of that chemical reaction. Ionic equation basically is not having any sort of spectator ion or any sort of irrelevant ions. So ionic equation is the a representation of ions and compounds. Those are bringing the net chemical change in that process, in that chemical reaction, that is said to be an ionic equation. How to write an ionic equation? There are basically four major steps. Number one, you must know about the solubility of the compounds, especially whenever you are going to deal with the aqueous reaction. If the reaction is happening in aqueous medium, then you must know the different solubility of the compounds. Those are present in that reaction, in that equation. Soluble compounds, group 1 elements compound, ammonium ion compounds, nitrate ion compounds, bicarbonate ions, HCO3 negative ion, bicarbonate ion compounds, H positive ion compound. Any compound that has ability to lose H positive ion into the aqueous medium is said to be the soluble. Mostly sulfate ion compounds and mostly halide ions like Cl negative ion, Br negative ion, I negative ion. These compounds are also soluble. Once again, group 1 metal compounds are soluble. Ammonium ion compounds are soluble. Compound having NH4 positive ion are soluble. Compounds having nitrate ion, NO3 1 negative ions are soluble. Compounds having bicarbonate ion, HCO3 1 negative ion, they are soluble. Compounds those can release H positive ion. All acids are water soluble. Usually sulfate ions are water soluble. Usually. Mostly halide ions are soluble with few exceptions. Now come towards the exceptions. Barium sulfate, strontium sulfate, lead sulfate and calcium sulfate. So barium sulfate is insoluble, strontium sulfate is insoluble, lead sulfate is insoluble, and calcium sulfate is said to be sparingly soluble or less soluble. These sulfates, barium sulfate, strontium sulfate and lead sulfate are said to be insoluble compound. That calcium sulfate is said to be less soluble compound. The next one exception is if halide ions, Cl, Br are I negative ions. If the halide ions are present with the silver, AgCl, silver halide, silver chloride, AgBr, silver bromide, AgI, silver iodide. If the halide ions are present with silver, this compound will again be the insoluble compound. If halide ions are present with lead 2 positive ion, PbCl2 is insoluble, PbBr2 is insoluble, PbI2 is also insoluble. So there are these two basic exceptions for sulfate and for chloride. Once again, barium sulfate, strontium sulfate, lead sulfate and calcium sulfate are supposed to be insoluble. AgCl, AgBr, AgI insoluble, PbCl2, PbBr2 or PbI2 again insoluble. Rest of the all sulfate compounds are water soluble as far as chemistry syllabus is concerned. Rest of the all halide compounds having halide ions are water soluble. Now come towards the insoluble. All metal carbonate, if the carbonate, CO3 2 negative ion, if the carbonate ion is in coordination with metal, if metal and carbonate sign are present, then all metal carbonate are insoluble except group 1, or in case of ammonium ion, that is not a metal. So ammonium carbonate is soluble. Group 1 metal carbonates are soluble, but rest of all carbonate are insoluble. The next one is all metal oxide and metal hydroxide. All metal oxide, all metal oxide and metal hydroxide are water insoluble, except if the metal is from group 1, that will be soluble. If oxide that is having NH4 positive ion, it will be soluble. Any oxide that is having strontium ion, that will be soluble. Any oxide that is having barium 2 positive ion, that will be water soluble. Once again, if any hydroxide, any metal hydroxide or other hydroxide, if it is having group 1 metal in its compound, it will be water soluble. Ammonium hydroxide, water soluble. Strontium hydroxide, water soluble. And barium hydroxide will again be the soluble. So this is the list which compound is soluble and which one is not, and you have to remember before going to mark or going to make an ionic equation. The next one is state symbol. We write the state symbols, basically aqueous, AQ for aqueous, S for solid, L for liquid, and G for gas. There are basically mainly 4 state symbols: aqueous, solid, liquid, gas. Aqueous mean water soluble. Any compound, if it is soluble in water, if it is dissolved in water, it can be written as aqueous. I mean soluble. Any compound that is solid and it is quite insoluble in water, it is written as S, right? If a compound that is a pure liquid and it is again insoluble liquid, I mean it is not water soluble. Any compound that is liquid and it is not water soluble, its state symbol will be liquid. Same is the case the molten liquid. I mean any sort of the fused liquid, any sort of fused compound that is said to be the molten liquid or molten compound. In case of molten liquid, we again mark liquid state symbol. G, gas. If the gas is water insoluble, we write G. If the gas is water soluble, we will again mark aqueous. If any liquid that is water soluble, we will mark aqueous. Aqueous mean any solid, any liquid, any gas if this compound, gaseous compound, liquid compound, or any solid compound, if it is water soluble, then its state symbol will be aqueous. The next one is write the ions. Now, for example, you know that HCl aqueous is written as H positive ion and Cl negative ion aqueous. H positive aqueous and Cl negative aqueous ion. But sometimes there are the few solutions that is having the covalent compound usually, and they do not make ions. They are not supposed to make ion into the solution. For example, the mixture of iodine in water. When we mix iodine with water, there is no any sort of ions. Same is the case with the glucose. When glucose is mixed with water, there is no any sort of ion. When we mix ethanol with water, again there is no any sort of ion. So sometime, or you can say the most of the time, covalent molecules, covalent solid, when they are solubilized into the water, they are said to be, they are reported as aqueous. I mean, they are water soluble up to very much less extent, or yes, sometimes appreciably they are soluble. But even though upon solubility, they are not making any sort of ion, except acid. If the covalent compound is water soluble and it is an acid covalent compound, then it will definitely make H positive ion and its negative ion. H positive ion aqueous and negative ion aqueous. If ionic compound is soluble in water, it will definitely make ions in water. It is true. I mean, all type of ionic compound, if they are soluble in water, they will make ions into the water. The next one is ionic compound also make ions in molten state. Any sort of molten ionic compound, there will be the mobile, liquid, positive and negative ion. In molten state, if there is the molten state of any ionic compound, it means that it's having positive and negative ions, and they are also written as with the liquid state symbol. The next one is remove spectator ions. Spectator ions are the ions those are not taking part in a chemical reaction. They will remain unchanged during the course of a chemical reaction. They remain same before and after the chemical reaction. They are said to be the spectator ions. So the last step is to remove the spectator ion. Now let's solve few examples. Come towards this example. This is the example of acid-base reaction or acid-alkali reaction. In this case, this NaOH is basically, NaOH is water soluble. HCl is again water soluble. This NaOH that is having sodium ion, this sodium ion belongs to group number 1. So group 1 hydroxide are soluble. HCl is an acid, so it is soluble. NaCl again is containing group 1 metal ion, it is soluble. And H2O is insoluble. So I'm going to mark the state symbol according to the nature of the solubility. Let's see over here. NaOH is aqueous, HCl is aqueous, NaCl is aqueous, and H2O is liquid. Now the next step is change aqueous into the ions. NaOH is basically can be written as Na positive aqueous plus OH negative ion aqueous plus come towards its HCl, H positive ion aqueous plus Cl negative ion aqueous, and goes to come towards this NaCl. It is in form of sodium ion aqueous plus Cl negative ion aqueous plus H2O. It will remain unchanged. There is no any sort of ion in case of H2O. So now let's see how many different ions those are not going to participate in this chemical change. They are same before and after the chemical reaction. Now you can see that sodium ion is a spectator ion and Cl negative ion is also present on the both side, I mean right hand side and left hand side. It is also a spectator ion. So after removing by the removal of spectator ions, we will get the final equation. OH negative ion aqueous plus H positive ion aqueous goes to H2O liquid. This is the final equation that is said to be the Ionic equation for acid-alkali reaction. All type of acid-alkali reaction, the answer is same, the answer is similar. That is this one. And once again, it is an acid-alkali reactions, neutralization you can say. Acid-alkali neutralization reaction, all type of acid-alkali neutralization reactions are having the same similar sort of equation. Come towards the next one. In this case, barium nitrate is an ionic compound. All nitrate are water soluble, so it is aqueous. It's an acid. All acids are water soluble. Barium sulfate, a famous exception, famous insoluble compound. It's not soluble, it will be solid. And again, nitric acid. It is an acid, and in addition to that, it is having nitrate ion, so it's water soluble. I am going to mark state symbol according to the nature of solubility. It's aqueous, it's solid, and it's aqueous. Now the next step is to change these aqueous compound into ions if there is the possibility of formation of ions. Let's see over here. I'm going to change. This is the barium nitrate. Here are barium 2 positive aqueous ions plus 2 moles of NO3 1 negative aqueous ions. In case of sulfuric acid, 2 mole of H positive ion aqueous, SO4 2 negative aqueous ions, and goes to. This is the barium sulfate that is insoluble. It will remain unchanged. It will remain unchanged. Barium sulfate solid plus. Come toward this one. Again, this is an acidic compound. So it can be written as 2 mole of H positive ion plus 2 mole of NO3 negative ion, aqueous and aqueous. So let's see and cancel out the spectator ions. Nitrate ions will be cancelled out. H positive ion as well. Remaining ions are barium 2 positive ion aqueous, SO4 2 negative ion aqueous goes to barium sulfate, goes to barium sulfate solid. So this is the final equation of this reaction that is said to be an ionic equation. The name of this reaction is precipitation reaction. The name of this reaction is precipitation reaction. And for this precipitation reaction, the ionic equation is Ba2 positive ion aqueous, SO4 2 negative ion aqueous goes to barium sulfate solid. So in this case, this equation is reflecting that barium 2 positive ion is going to react with the SO4 2 negative ion to make barium sulfate. This is the basic chemical change that is happening in this chemical reaction. This is the basic chemical change that can be observed in this reaction, that is said to be the net chemical change, right? So this is an ionic equation for this sort of precipitation reaction. Now come towards the next one. Next example reaction, that is once again an acid-base reaction. This is the calcium carbonate, that is a base, H2SO4, that is an acid. Calcium sulfate is a simple ionic compound, a salt. CO2 is a gas, H2O is a liquid. This calcium carbonate is not an alkali, it's a base. It's not an alkali. It's a base, yes it is true. It is water insoluble compound. So I'm putting S over here. All acid are water soluble, I'm putting aqueous over here. This calcium sulfate is again supposed to be less soluble, and I'm putting S over here. This CO2 is less soluble, sparingly soluble under normal condition in water. Again, I'm putting G, gaseous. It is almost insoluble. And H2O is again insoluble into its like molecule, like water molecules. So there is only one species present that is in form of aqueous. This one, that is sulfuric acid. No other species present that is having the aqueous ions, or the aqueous that is soluble in water. And yes, it is having the ions, H positive ion and sulfate ion. So as far as my opinion is concerned, this equation is not having any different or any other sort of ionic equation. Maximum we can write it over here like that. CaCO3 solid plus 2 mole of H positive ion plus SO4 2 negative ion, here is aqueous. Again aqueous goes to CaSO4 solid plus CO2 gas plus H2O liquid. So this is the maximum variant, the maximum possible variant of ionic equation for this reaction. I think, there is no difference between these two equations, and this equation cannot be changed further into the different other sort of precised equation, ionic equation, and so on. Come toward the next example. Again calcium carbonate, HCl, CaCl2, CO2 and H2O. This time once again it is insoluble. I am putting S over here. HCl, it's an acid, definitely it is soluble in water. I'm writing aqueous over here. Calcium chloride or halides are water soluble except lead and silver, and there is no lead, no silver, it's a calcium, so I'm putting aqueous over here. CO2 is insoluble, I'm putting gas G over here. H2O is a liquid, I'm putting liquid over here. The next step is to make aqueous into the ions if there is the possibility of formation of ions. So calcium carbonate CaCO3 solid plus 2 mole of H positive ion aqueous plus 2 mole of Cl negative ion aqueous goes to Ca2 positive ion aqueous. It's soluble. CaCl2 is water soluble. 2 mole of Cl negative ion aqueous plus CO2 gas and H2O is the liquid. Now let's see what ions are the spectator ion. Only one, I think, if I'm not wrong. So I'm going to cancel out Cl negative ion that is present on the both sides. So the net remaining equation will be or can be written as CaCO3 plus 2H positive ion aqueous, it's a solid, goes to Ca2 positive ion aqueous plus CO2 gas and H2O, that's a liquid. So this is the final equation that is said to be, that can be called as an ionic equation for this type of acid-base reaction. And now come towards the next example. NH3, HCl, NH4Cl. There are once again, one is the acid. This is water soluble. We can write it aqueous over here. NH3 is less soluble, is least soluble. It's a base and it's a weaker base. I'm putting this time G, gas, over here. You can write aqueous as well, but at the moment I'm writing gas over here, G. You can see that I'm going to put aqueous over here. Ammonium chloride is water soluble. So the soluble compound can be changed into ions. HCl will make ion, NH4Cl will make ion, and we write NH3 in gaseous state plus H positive ion aqueous plus Cl negative ion aqueous goes to NH4 positive ion aqueous plus Cl negative ion aqueous. Once again, the common ions are Cl negative ion and they will be cancelled out. The remaining equation will be, this is the compound, gaseous compound NH3 plus H positive ion, that is aqueous, going to make, finally the net change is going to be formed for to make NH4 positive ion, that is aqueous. So this is the net chemical reaction, net chemical change for such type of acid-base reaction. Let's see the next one. F2, fluorine plus potassium iodide, iodine, potassium fluoride. Fluorine is a gas that is least soluble, almost insoluble. So I'm putting G, I'm writing G over here, gas. Ki, all salt are water soluble, all compounds are water soluble, those are having group 1 metals, that is the potassium. So again it is aqueous, all group 1 compounds are water soluble. What about iodine? Iodine is sparingly soluble, or you can say the more soluble than that of F2. So I'm putting aqueous iodine, I'm putting AQ over here. What about Kf? This potassium fluoride, once again it is having group 1 metal, and I am putting aqueous over here. Again it's soluble in water. Now let's see which type of soluble compound can be changed into ions. This potassium iodide can be changed into ions. This iodine cannot be changed into ions. This potassium fluoride can again change into ions. Alright, so F2 gas plus potassium positive aqueous plus I negative aqueous goes to I2 aqueous, but it's not going to make ions into the water. And again K positive aqueous, potassium ion aqueous, and F negative ion aqueous. The spectator ion is the potassium ion, so I'm going to cancel it out. And the remaining answer will be, to balance this chemical equation, we will have to put 2 over here and 2 over here. So I'm again marking 2, 2, 2 and 2. So the remaining equation will be F2 gaseous plus 2 I negative ion aqueous goes to I2 aqueous plus 2F negative ion aqueous. This is the final equation that is said to be the ionic equation for this said reaction. Come towards the next example. Iron, that is a pure element, is going to dissolve or going to react with copper sulfate, CuSO4, that is going to make FeSO4 plus copper. This iron is basically water insoluble. I'm writing as solid over here. Copper sulfate is water soluble. I'm writing aqueous over here. Iron sulfate, all sulfate are water soluble. All sulfate are water soluble except lead barium, strontium, and calcium. So again, FeSO4 is also water soluble. This is the pure copper and pure metal. Usually pure metal except group 1 are water insoluble. So I am writing S over here. I am writing S over here. Now come towards the ions. I'm going to change aqueous material into the ions. Let's see over here. I mean, it can make Cu2 positive aqueous plus SO4 2 negative ion aqueous goes to, it is going to make Fe2 positive ion aqueous plus SO4 2 negative ion aqueous. The remaining species will remain in solid state. They are not aqueous. Fes solid, Cu is again in form of solid. Now let's see which one is the spectator ion, that is sulfate ion. So I'm removing the sulfate ions, and the rest of the equation will be, now this is the final equation that is said to be the ionic equation. So this is the final ionic equation for this reaction. Iron solid plus Cu2 positive ion aqueous goes to iron 2 aqueous plus copper solid. That is the ionic equation for this said reaction. Come toward the next. Now come toward the molten reaction. If the iron piece of an iron solid is dipped into the molten copper sulfate. So molten copper sulfate is having L, its state symbol, and it's having, initially this is solid. Come towards FeSO4, again it will be, liquid because it's a molten, and copper that is going to be formed if we are going to treat this reaction at high temperature. Once again it will be in liquid state. Now come towards, in case of molten, liquid ionic compound can be changed into ions, right? So I'm going to change this copper sulfate, Cu2 positive liquid plus SO4 2 negative ion liquid goes to Fe2 positive liquid plus SO4 2 negative ion liquid plus Cu liquid, and on the left hand side iron is initially solid, you can say. So which one ions are the spectator ion? Oh, I think there is only one spectator ion that is not taking part overall the chemical change, and the overall change is because of iron solid that is going to displace copper 2 positive ion liquid, and it is changing itself into iron 2 positive ion liquid, and it is making copper 2, changing copper 2 positive ion into pure copper solid. You can write solid, you can write liquid as well. So this is the basic ionic equation in molten state. That's all about this ionic equation. How can you form the ionic equation? How can we make the ionic equation? Don't forget to subscribe my channel and like, share, hit the bell icon for incoming notification. Thank you very much. Have a nice day.